Think back to when you were a kid waiting for summer break. Those last few weeks of school felt like they stretched on forever. Each day was its own little lifetime. Christmas Eve was practically unbearable. Time moved like thick, slow honey. Now think about last year. Can you even remember where it went? One week bleeds into the next. You blink, and somehow it's December again. You say, that was only a few months ago, about something that happened 3 years back. Here's what nobody ever told you. This isn't just a feeling. It's not you being dramatic or distracted. Time is genuinely moving faster for you, and there's a real, documented scientific reason why. And once we understand it, we actually get the power to slow it back down. So what's actually happening? Why does time feel so different now compared to when we were children? And more importantly, is there anything we can do about it? The answer involves the way your brain stores memories. A French philosopher from 1897 and a physicist who studied why birds fly. These ideas have been sitting in scientific journals for decades. Nobody packaged them together and told you. But today, we're going to change that. The first explanation comes from a French philosopher named Paul Janet, writing in 1897. His idea was almost embarrassingly simple, and it's still considered one of the most accurate explanations we have. Here it is. Our sense of time isn't absolute. It's relative to how much life we've already lived. When you are 5 years old, 1 year represents a full 20% of your entire life. That's a massive chunk of everything you've ever experienced. So it feels enormous, because it is enormous, to you, at that age. But when you're 50 years old, 1 year is only 2% of your life. The same 365 days, the same 8,760 hours. But your brain is now measuring it against 50 years of lived experience, instead of 5. It gets lost in the crowd. Think of it like this. If you had 1 coin, that coin would mean everything to you. If you had 1,000 coins, that same coin would barely register. Time works the same way. The more of it we accumulate, the less weighty each new piece feels. The second explanation goes even deeper, into how your brain actually records time as it's happening. Your brain doesn't record every moment equally. It prioritizes the new and the novel. When something is unfamiliar, a new place, a new person, a new experience, your brain fires up and says, "Pay attention, record this carefully, this matters." It encodes these moments in high detail, like saving a file in maximum resolution. But when something is familiar, the same commute, the same lunch, the same routine, your brain barely bothers. It's already seen this. It saves just a faint trace, like a low-resolution thumbnail. It's efficient. It's just doing its job. But the side effect is enormous. When you look back at a period full of new experiences, a year abroad, your first job, falling in love, it feels long and rich and full. Your brain has hundreds of detailed files from that time. But when you look back at a year of comfortable routine, it collapses into almost nothing. A handful of blurry thumbnails. It feels like it lasted about 3 weeks. As children, almost everything is new. Every single day contains discoveries. The world is one giant first experience. As adults, we've seen most of the world's basic shapes. We stop noticing. And when we stop noticing, our brain stops recording in detail, and time compresses. Then there's a third theory, and this one comes from an unexpected place: physics. Professor Adrian Bejan, a physicist at Duke University, published a paper studying how the brain processes visual information over a lifetime. What he found is this. As we age, the physical connections in our brain, the neural pathways that carry signals, degrade slightly and become less efficient. The signals travel just a little slower. This means your brain generates fewer mental images per second as you get older. As a child, your brain is rapidly firing, generating a rapid stream of mental snapshots, like a film reel running at high speed. As we get older, that reel slows down. We're generating fewer frames for the same stretch of clock time. The result? The same amount of real time contains fewer mental moments for an older person than a younger one. Less happens, subjectively, and so it feels shorter. The film plays fewer frames, but the clock keeps ticking at the same rate. So here's where we are. There are 3 separate forces all pushing in the same direction. Time is proportionally smaller relative to our total life. Our brain is recording fewer novel moments in detail, and our internal frame rate has literally slowed down. No wonder it feels like the years are slipping away. And this is the part that nobody prepares you for. Nobody sits you down at 22 and says, by the way, as your life gets more comfortable and routine, your experience of time is going to start compressing. The more you coast, the faster it goes. It just happens, quietly, invisibly, until you're looking back wondering where a whole decade went. But here's the thing. Understanding the mechanism changes everything. Because once we know why this is happening, we can see exactly what to do about it. If time accelerates because our brain stops recording new things in detail, then the solution is to give it more to record. And the beautiful part? We don't need to quit our jobs or move to another country to do it. Novelty is the key. Novel experiences force the brain back into high-detail recording mode. This doesn't have to be dramatic. Walk home a different way. Try a food you've never had. Have a conversation with someone whose life looks nothing like yours. Learn something that makes you feel slightly stupid at first. Go somewhere you've never been, even if it's just a part of your own city. Research consistently shows that people who look back on periods packed with new experiences, even small ones, remember those periods as feeling longer, richer, and more alive. The memories are dense. The folder is full of high-resolution files. There's also something to be said for presence. When we're distracted or numb, the brain records even less. When we're genuinely paying attention, fully in a moment, noticing it, the brain flags it as important and stores it properly. This is why a single, deeply present afternoon can feel more substantial in memory than an entire automated week. In other words, the more we actually show up to our own lives, the more of it we get to keep. Here's what to take away from this. Time speeding up isn't a punishment. It's feedback. The brain is telling us something, that it's running low on new material, that life has settled into patterns that no longer surprise it. That's not a tragedy. That's an invitation to stay curious, to keep collecting first experiences, to keep being someone who notices things. The people who reach the end of their lives feeling like they truly lived, they're not the ones who did the most impressive things. They're the ones who stayed present for the ordinary ones. They filled the folder. They kept the frame rate high. We already know this is possible because we've felt it. We've all had those rare days that felt impossibly full, where at 9 p.m. you could hardly believe it was the same day you woke up on. Those days aren't luck. They're a clue. And now we know how to follow them. But here's a question that might already be forming. If novelty and presence are the answer, why is it so hard to actually stay present? Why do so many of us drift through entire days, entire weeks, on a kind of autopilot, going through the motions without really being there at all? It turns out, that's not a character flaw. It's not weakness or laziness. Scientists have a name for the state most of us live in, and understanding it might be the most important thing we ever learn about our own minds. That's what we're getting into next time. That video is ready and waiting right now. Click it, because once you see what your brain has been doing without your permission, you'll never think about your days the same way again. Click the video on your screen. We'll see you there.